I want to show you guys how waves work and the difference between the two general classes of waves. Waves transfer energy. So if I give this a little bit of energy, that energy transfers up and transfers back down.
That looks so cool.
So just like when you pluck the string, you pluck it, and that vibration goes up and down the string. Now, when you pluck the string in the middle, hold yours tight down at the back. Yep. Let me
exaggerate it more.
Let me tighten it up a little bit. It'll work better. Okay. So when you pluck the string in the middle, it tends to do this, and that's vibrating at a half of a wavelength. Because as you can see, this curve is basically half of a wave. But if we pluck it away from the middle at about a quarter of the way up it, we can get a second node. So that section in the middle isn't actually going anywhere. See this spot in the middle that stays right next to that spot in the floor?
Just pivoting there.
So that is a full wavelength. And if we go faster, and if I was coordinated, we could end up getting 1.5 or 2 wavelengths.
I can picture that being a screensaver.
And if you go faster still, you can get more wavelengths in. Each time you make it faster, the wavelengths get shorter. And that's one of the things about waves. As you get shorter and shorter wavelengths, they're moving faster, and you're getting a higher pitch. So that has to do with sound. Now that's one type of wave. That's the type of wave that happens in the string. There's a different type of wave that happens in air. Air doesn't vibrate back and forth like that. Air vibrates by compressing and stretching out. And that looks like this. Hello. See that pulse run down and back? That's a compression pulse.
That's cool.
So this is what they call a longitudinal wave.
You guys should see
the
this
wave
from my
energy runs along the wave, so a longitudinal pulse. This is what happens in air. So when the string is going back and forth like this, it's pushing the air, and the air between the string and your eardrum is doing this. It's getting pulled and pushed, compressed, and actually the term for it is rarefied. So compression and rarefication. That's called the longitudinal wave. We have a lesson that shows how you take a transverse wave on a string, make it into a longitudinal wave in air, or how you take a transverse wave in a string and make it into a transverse wave in a magnetic pickup that goes to an amp, that then sends the transverse wave to a speaker, which turns a transverse wave back into a longitudinal wave from moving air. So we got that coming up as a lesson. And the cool part is, now you can just let go of that end. Slinkies are a lot of fun.